Welcome to Mind Research Rewired. We unveil scientific truths to transform confusion into clear thinking. Unlock a sharper, more effective you based on proven research. Subscribe now and elevate your life.
Have you ever wondered why you just know something is true, even when maybe the evidence is a little shaky? Or why, when you've put a ton of effort into something, it's incredibly hard to walk away, even if it's clearly, a losing battle.
Oh, definitely. We all do it.
Yeah, we all make these decisions, big and small, every single day, and often we don't even realize the sort of systematic patterns our minds fall into.
Exactly.
So today we're taking a deep dive into those very patterns, cognitive biases.
Right.
And these aren't just random mistakes, they're systematic mental shortcuts. Almost inherent deviations from pure rationality that, they influence our judgments.
Profoundly influence them.
Yes.
And sometimes lead us to outcomes that aren't exactly optimal.
Right. So our mission in this deep dive is really to uncover why. Why are these biases so incredibly pervasive, so systematic across different people, different situations?
Even when we think we have all the information.
Exactly. Or all the time in the world to decide. We're going to explore a new kind of unifying perspective that goes quite a bit beyond the common understandings.
Indeed. And the central question we'll really tackle is this. How can we explain why human thinking so consistently violates, basic rules of logic, probability, and maybe even more puzzling, why do we often feel so incredibly confident in these decisions, even when the evidence is scarce, or maybe even points the other way?
It's a real paradox.
It truly is. And it just begs for a deeper explanation, doesn't it?
All right, let's dig into this then.
Okay.
So we know our brains are pretty good at taking shortcuts, right? These mental shortcuts, heuristics.
Yep, essential for getting by.
Especially when we're short on time or maybe just overwhelmed with information. And look, for a lot of daily life, these shortcuts actually work remarkably well.
They do. They let us navigate complex situations quite efficiently.
But as we just touched on, these exact same shortcuts can also lead to predictable patterns of error, what we label cognitive biases.
Those suboptimal decisions, yes.
Yeah.
And what's truly striking here and really demanding of a deeper look is just how systematic and persistent these biases are. They are surprisingly consistent across different people, different cultures, different conditions. It's not really about individual character flaws or, lack of intelligence.
No.
It suggests something more fundamental is going on. It points towards a more generic explanation for why these patterns keep showing up.
It's true. Take confirmation bias, for instance.
Classic example.
Right. That's where you actively look for arguments that defend what you already think, instead of genuinely looking for, unbiased truth.
Or you interpret ambiguous evidence in your favor.
Exactly. Or think about the pseudo-certainty effect, where you become incredibly risk-averse when you see a positive outcome on the table.
You want to lock it in.
But then surprisingly risk-seeking to avoid a negative one, even if the probabilities are technically the same.
Right. These aren't isolated incidents. They're really common, almost universal patterns of thinking.
Okay. Now, over the years, the scientific community has proposed, 3 main theoretical perspectives on where these cognitive biases come from.
Right. The standard explanations.
And while each one offers some valuable insights, the sources we're diving into today argue they don't quite provide that full underlying explanation, especially for their pervasiveness.
Let's break them down. The first is the cognitive psychological perspective.
Okay.
This view largely attributes biases to limitations in our information processing capacity. You often hear the term bounded rationality.
Right, Herbert Simon.
Exactly. The core idea is that we use simple heuristics because our brains can only process so much information, particularly in complex situations or when we're under time pressure.
Which makes intuitive sense.
It does. And this led to those popular dual process frameworks, distinguishing between, say, fast, intuitive type 1 processes and the slower, more deliberate type 2 processes.
System 1 and System 2 thinking, Kahneman's terms.
Precisely. But what's often overlooked, or maybe not emphasized enough, is that this explanation can become a bit tautological, a bit circular.
How so?
Well, we infer the limited capacity from observing the biases themselves, and then we use that inferred limited capacity to explain the biases.
Oh, okay. I see the loop.
Right.
Wow.
And it also struggles to account for why certain biases, like, say, superstition or overconfidence, tend to persist even when we're fully aware of them. even when we have plenty of time to think things through more carefully.
Good point.
And maybe even more surprisingly, some biases, like the conjunction fallacy, thinking two things together, are more likely than one alone, or base rate neglect.
Ignoring the overall statistics.
Yes. Those actually seem to involve processing more information, or at least integrating information in a complex way, not less, which kind of contradicts the idea that limited capacity is the sole driver.
Okay, so that's the cognitive view and its potential limits. What's the second one?
The ecological perspective.
Right.
This one suggests that biases arise from a mismatch. A mismatch between our learned heuristics, the shortcuts we pick up from experience.
And the context where we're applying them.
Exactly.
Yeah.
It's like using a tool that works perfectly in your natural environment, your everyday life, but then it leads you astray when you apply it in an unfamiliar setting, often like an artificial lab experiment.
Okay, so the context is key.
Yes. But the tricky question that immediately comes up is, how do you precisely define when a problem sufficiently differs from a natural context to reliably trigger a bias?
Yeah, where's the line?
It's fuzzy and doesn't fully explain the remarkable consistency of these biases across so many different people and varied situations, regardless of their specific, ecological niche.
Okay. And the third main view?
That would be the evolutionary perspective.
The evolutionary psychology angle.
Right. This view proposes that biases stem from heuristics that evolved over long periods. They were adaptive for our ancestors, helped them survive and reproduce in ancient environments. But now, these same evolved tendencies lead to maladaptive behavior in our current, more artificial, modern settings.
Can you give an example?
Sure. Think of the action bias. That urge to do something even when doing nothing is statistically better. Maybe that helped avoid unseen dangers in the past. Or loss aversion.
Feeling losses more strongly than gains.
Exactly. Maybe that helped conserve precious resources. Or the scarcity heuristic, valuing things more just because they're rare.
Okay.
Now, while this perspective is certainly relevant, especially for some social behaviors, it primarily addresses a more limited set of purely cognitive biases, particularly those related to social psychology. It doesn't quite seem to cover the full spectrum, especially biases in logical reasoning or probability judgments.
So when you step back and look at these three traditional views, cognitive limits, ecological mismatch, evolutionary baggage, they all seem to have significant gaps, don't they? They don't fully explain why these biases are so systematic, so consistent, so persistent across almost everyone.
Exactly. Or why specific biases pop up, like why overconfidence instead of underconfidence, or why confirmation bias, seeking support, rather than, say, a disconfirmation bias.
Right. Why these particular patterns?
And this really prompts an important reevaluation. What if the origin of these biases is much deeper, much more fundamental than we previously thought? Because, intriguingly, human-like biases aren't just in humans, they've been observed in animals too. And even, get this, in artificial neural networks, AI.
Really? AI shows biases?
Yeah, machine learning programs.
No.
For instance, when they're trained on large amounts of text data from the internet, they can actually pick up and exhibit human cultural stereotypes embedded in that data.
Wow.
It strongly suggests something far more fundamental is at play than just, a human cognitive shortcut or a specific evolutionary relic.
Okay, so that naturally leads us to this newer idea, this radical proposal from our source.
Yes.
What if cognitive biases aren't just errors or shortcuts we can somehow fix or avoid? What if they are, in fact, inevitable tendencies?
Baked in, so to speak.
Exactly. Intrinsically linked to the inherent, maybe even hardwired design characteristics of our brain itself.
This requires a fundamental shift in how we think about the brain. We need to move away from that very popular computer metaphor.
Brain as hardware, mind as software.
Right. Instead, we need to picture the brain as what it is, a biological neural network, one that's primarily optimized over millennia for concrete biological, perceptual, and motor functions.
Things crucial for immediate survival.
Absolutely. What we might call type 1 capabilities, catching a ball, recognizing a face, navigating terrain. Now, if we connect this to the bigger picture of brain evolution,
Okay.
higher cognitive functions like abstract reasoning, complex calculation, logical deduction, type 2 thinking, these developed much later in our evolutionary history. And perhaps surprisingly, they are less optimized for our brain's original core design.
Wow. Okay, that is a huge shift in perspective. So you're saying biased decision-making is essentially, it results from a fundamental mismatch.
A mismatch, exactly, between what our brain was originally built for those lightning-fast perceptual motor tasks.
Spotting a predator, grabbing food.
Right, and the demands of many modern conceptual or analytical problems, like predicting stock market trends or assessing complex medical risks, or even just doing formal logic problems.
So that explains why our brains can do incredibly complex things effortlessly, like understanding speech in a noisy room, but then struggle with seemingly simpler logical puzzles or probability calculations.
Precisely. It's almost like using a highly specialized tool, say, a system built for pattern recognition for a job it wasn't primarily designed for, like abstract symbolic manipulation.
Like using a hammer for fine needlepoint.
Something like that, yes. So to really grasp this, we need to dig into 4 basic operating principles. Principles inherent to all biological neural networks, including our brain.
Okay. 4 principles.
And these aren't mutually exclusive. They often work together. They're additive, contributing to biases in various ways.
Got it. What's the first one?
Principle 1. The association principle.
Association. Okay.
This principle basically states that the brain is fundamentally associative. It's constantly, automatically searching for relationships, for coherence, for patterns in whatever information is available.
Even if those relationships aren't really there in reality.
Even then. It's how we excel at pattern recognition, which is, of course, a hugely powerful survival tool. Spotting correlations helps predict the future.
But how does that work at the neural level?
Well, it translates pretty directly to that classic neuroscience idea. Cells that fire together, wire together.
Hebb's rule. Right. Donald Hebb.
Exactly. It means that the connections between neurons, the synapses, are continuously adapted. They get stronger when neurons activate simultaneously or in close succession. The more often 2 things happen together in your experience, the stronger the mental link becomes.
And you can see this leading to biases, right? Like superstition.
Absolutely. You perform some random action, maybe you wear your lucky jersey, and then your team wins. Boom. Your brain makes an association, even though it's pure chance. Now you feel compelled to wear the jersey every game.
It gives you that feeling of control, even when there isn't any. The control illusion.
Precisely. Or think about the conjunction fallacy again. Why does a combination of coherent conditions, like, say, the dramatic increase in oil prices, led to a 30% drop in oil consumption?
Yeah.
Why does that feel intuitively more likely than just one of those conditions alone, like oil consumption decreased by 30%?
Because it tells a better story. It seems more connected.
Exactly. The association principle makes coherence feel like likelihood. The brain links the plausible cause and effect, making the combined scenario seem more probable, even though logically a single event is always more probable than that event plus another one.
So the big takeaway here is that our brain's relentless drive to find patterns, which is a huge strength, can become a vulnerability in abstract reasoning. It makes us see connections, causality, or likelihood where it doesn't actually exist.
Correct. That's the association principle. Ready for the next one?
Yep. Lay it on me.
Principle 2. The compatibility principle.
Compatibility. Okay, what's that about?
This principle describes how the brain isn't a blank slate passively receiving information. It actively requires new information to be compatible or consistent with its existing state, its current knowledge, expectations, even its mood.
So we tend to see what we expect to see, or what fits.
In a manner of speaking, yes. Information that aligns with our pre-existing mental models is processed more easily and readily accepted.
And the neural basis for that?
It relates to processes like priming, potentiation, and facilitation. Basically, once a neuron or neural pathway has been activated, it's easier to activate it again shortly afterward.
Like warming up an engine?
Sort of. So information that's consistent with what was just active in your brain gets processed more efficiently. It fits right in.
And this manifests in real-world biases, too.
Oh, absolutely. Think about confirmation bias again.
Right, seeking out confirming evidence.
You selectively notice, interpret, and remember information that confirms your existing beliefs or hypotheses. Contradictory evidence often gets ignored, dismissed, or scrutinized much more harshly.
It just doesn't feel right.
Exactly. It's not compatible. Or consider the sunk cost fallacy.
Ah, yes, throwing good money after bad.
Right. Your tendency to keep investing time, money, or effort into a losing venture just because you've already put so much into it. Why? Because changing course would be incompatible with your past decisions and commitments.
It feels inconsistent. Like I always feel I have to finish a terrible movie if I'm already an hour in.
That's the feeling. It's about maintaining consistency with what you've already done or believed.
So what's particularly striking here then is how this principle helps explain why it's so fundamentally hard to change our minds.
It really does.
or to accept information that clashes with our established views. Our brains are literally wired to prefer what's familiar and consistent. It's metabolically easier, neurally smoother.
Precisely. Incompatible information causes cognitive dissonance, a kind of mental friction.
Okay, that's compatibility. What's number 3?
Principle 3, the retainment principle.
Retainment. Okay.
This principle unpacks the idea that once information is processed and encoded by the brain, once it becomes part of the wetware, as our source puts it.
Part of the structure.
Yes. It cannot simply be ignored, erased, or denied as if it never happened. It always leaves a lasting impact, becoming integrated into your neural architecture.
So you can't just delete a memory or a piece of knowledge.
So not really, no.
Yeah.
This is deeply linked to neuroplasticity, the brain's ability to change its structure and function based on experience. The accumulation of information causes physical synaptic changes, literally modifying neural circuits.
Okay.
And when new information comes in, like finding out the outcome of an event, it seamlessly blends with your existing memories of the situation before the outcome was known. This integration makes the original, pristine memory often inaccessible.
You can't rewind to exactly how you felt before you knew.
It's very difficult, often impossible. Your brain doesn't store things in separate, untouched files like a computer might. It constantly integrates and updates.
And the bias example here.
Hindsight bias is a perfect illustration.
The I knew it all along effect.
Exactly.
Yeah.
You look back at a past event, now that you know the outcome, and you erroneously perceive it as having been much more predictable or likely than it actually seemed at the time.
Oh, of course that was going to happen.
Right. Because the outcome information has been retained and integrated into your memory of the pre-outcome situation. Or think about the endowment effect.
Where you value something more just because you own it.
Yes. You value an item you own much more highly than you'd be willing to pay to acquire it if you didn't own it. Why? Because ownership itself is information that gets retained and integrated, changing your valuation. It's now yours, part of your extended self in a way.
Making it harder to give up.
Much harder. So the core implication here is profound. Our brains don't simply unsee or unknow things. Once information is in, it integrates, often making past judgments seem deceptively obvious in retrospect because the outcome has already reshaped our memory the lead up.
Okay, retainment. That leaves one more principle.
Principle 4, the focus principle.
Focus. All right.
This principle states that the brain operates much like a spotlight or a magnifying glass. It focuses intensely on whatever information is currently dominant, salient, or readily available.
What's right in front of you?
Exactly. While largely ignoring other relevant but less obvious or less immediately accessible information. Daniel Kahneman famously summarized this as WYSIT.
What you see is all there is.
Precisely. We act as if the information currently in focus is the only information that matters, or even the only information that exists.
And the neural mechanism behind that focus.
It's thought to involve lateral inhibition. It's a process where highly active neurons tend to suppress the activity of neighboring less active neurons.
So the strong get stronger and suppress the weak.
In effect, yes. It amplifies small differences in activation, allowing certain information or associations to quickly become dominant while actively suppressing other, potentially conflicting or merely less salient information. This creates functional blind spots in our awareness.
Okay, I can see how that would lead to biases. Examples.
The availability heuristic is a prime example.
Judging likelihood by how easily examples come to mind.
Right. You judge how frequent or important something is based purely on how easily instances pop into your head, which means you systematically ignore missing data or information that's harder to retrieve from memory. It's the outer sight, out of mind phenomenon.
If it's not salient, it doesn't count.
Pretty much. Or think about the overconfidence bias.
Believing we're more accurate than we are.
Yes. You overestimate the accuracy of your own judgments, estimations, or predictions. Why? Because you're focusing intently on what you do know, the evidence supporting your conclusion, and failing to adequately consider what you don't know, the gaps in your knowledge, the counter-evidence. WYSIT.
What you see is your own clever reasoning.
And not the vast realm of uncertainty or missing information. And then there's survivorship bias.
Focusing only on the winners.
Exactly. You draw conclusions by looking only at the successful outcomes or the survivors in some process, the companies that thrived, the patients who recovered, the planes that returned.
And completely overlooking all the failures, the ones that didn't make it, the data you don't see because it was eliminated. My success at, say, making dinner tonight often makes me conveniently forget all the absolute kitchen disasters I've had in the past.
A perfect everyday example. The focus is on the present success, not the hidden graveyard of failed attempts.
So this focus principle really points to a deeper truth about why we so often miss crucial information and why we tend to be overconfident in our limited understanding. Our brain's natural spotlight inevitably creates these blind spots.
That's the idea.
Yeah.
These 4 principles, association, compatibility, retainment, and focus working together, provide a powerful, neurobiologically grounded framework.
A framework that offers a more unified explanation for biases.
Exactly. It provides a potentially unifying and binding explanation for the vast and often remarkably similar array of cognitive biases we observe across so many domains. It helps bridge that historical gap between purely cognitive descriptions of bias and the underlying neuroscientific mechanisms. It shows how the brain's fundamental architecture can actually drive these behaviors.
And what's truly fascinating, going back to what you said earlier, is that this framework helps explain why these biases aren't just uniquely human quirks.
Right. It explains why similar bias patterns are observed in animals and even emerge in artificial intelligence systems. It strongly suggests there's a fundamental common underlying mechanism inherent to how any complex adaptive neural network processes information and learns from its environment.
It's about the network structure itself.
It seems to be.
Yeah.
And it also sheds incredible light on the nature of expertise.
How so?
Well, think about domain-experienced experts. They can often solve incredibly difficult problems almost intuitively, without conscious deliberation.
Right, the gut feeling of an experienced doctor or firefighter.
Exactly. This framework suggests that extensive, consistent training within a specific domain builds and strengthens the correct neural associations. It essentially hardwires unbiased or optimal judgments at a basic neural level for problems within that domain.
So their intuition isn't magic, it's highly trained pattern recognition.
Precisely. Their brains have been trained through repeated experience to automatically associate cues with appropriate responses, often bypassing the slower, more effortful, and potentially more bias-prone type 2 thinking for those specific tasks.
Okay, so this realization that biases might be, in a sense, hardwired tendencies intrinsic to our brain's very design, that's really powerful.
It is.
It really pushes us beyond that old, maybe simplistic computer metaphor of the brain, the idea that we just need better software or debugging towards a more accurate, more biological neural network perspective. Our brains aren't general-purpose computers. They're evolved biological organs with specific strengths and inherent tendencies.
And understanding this is crucial, I think, because it helps us better predict where and why biases are likely to occur, and potentially how to counteract them more effectively. It affects almost every level of our daily lives, doesn't it?
Absolutely. From personal choices about health or finance
to complex business strategy decisions, legal judgments, even large-scale public policy.
Yeah. And it explains why our automatic or intuitive responses, driven by these underlying principles, feel so overwhelmingly real and compelling.
And why we often feel that strong emotional reluctance to correct them, even when, rationally, we might know we should. It feels like fighting against our own nature.
So to kind of wrap up the core idea here, our brains, brilliantly optimized for survival and those rapid perceptual motor tasks, come with these built-in tendencies, these biases.
Yeah, they're features, not just bugs in a sense.
Features that are incredibly efficient in some contexts, letting us navigate the world quickly. But they can definitely lead us astray in others, especially when dealing with abstract concepts, probabilities, or situations outside our evolutionary experience.
That sums it up well. Which leaves us with a rather provocative thought, perhaps.
Go on.
If our brains are indeed inherently wired for these biases stemming from these fundamental neural principles, what responsibility does that place on us as conscious thinking beings?
To just be aware of them.
Awareness is the first step, certainly. But perhaps more. Responsibility to actively understand them, identify their influence in our own thinking, and maybe deliberately try to mitigate their impact, especially when the stakes are high.
That's a deep question. What stands out to you listening to this deep dive about your own decision-making patterns? Where might these principles be playing out in your own life? Something to think about.
Yes, that is something for all of us to think about. We have come to the end of today's deep dive. If you like the content of our podcast and learned something useful, please subscribe to support our channel. We will continue to unveil cutting-edge scientific papers to bring clarity to your thinking and elevate your life. Thank you.